So we completed parts A and B. Let's look at part C. So the input signals at VN1 and VN2 come from hydrophones with inbuilt buffer circuits with a recommended load resistance of 10 k ohms. The maximum output for each hydrophone is 35 millivolts peak. If the amplifier output must not exceed 1 volt peak when both hydrophones are producing maximum signal, and both channel gains must be matched to within 0.1 of a dB, choose suitable values and tolerances for R and RF. Discuss carefully why you have chosen those values and what limited the range of values you can choose. Now, at first glance, that looks like quite an interesting challenge. But if we go back up to the circuit and we see that we've got these two hydrophones here are both connected to a resistor R. This point here is a virtual earth. In other words, the load on this VN2 hydrophone is R, and the load of this VN1 hydrophone is similarly R. And looking at what it says they should have inbuilt buffer circuits, and they should have a recommended load resistance of 10 k ohms. So that means that these two resistors here and here should be 10 k ohms to match what this question says. We then go on and say the maximum output from each hydrophone is 35 millivolts peak. If the amplifier output must not exceed 1 volt peak, when both hydrophones producing maximum signal and both channel gains must be matched to within 0.1 dB, choose suitable values for R and RF. Discuss carefully why you have chosen. So let's have a little look. And let's see what we can drive from this one here. Share screen, advanced, second camera, share. Right, so we've answered part B and part C. So Vmax, each hydrophone equals 35 millivolts. R load equals 10 k ohms. Therefore, make R equal to 10 k ohms. Vout max must be equal to 1 volt peak. And there's a couple of ways you can kind of tackle this question. So Vout max is 1 volt peak for both hydrophones. Therefore, Vout max, one hydrophone equals 0.5 volts or 500 millivolts. equation for inversion amplifier equals minus RF over R, gain equation, which equals V out over V in. Which equals 500 millivolts over V in, which was 35 millivolts. $14.28. Therefore, RF must equal 2.86 k ohms. But we haven't used all the information in the question. What the question also says that the both channel gains must be matched to within plus or minus 0.1 of a dB. So choose suitable values and tolerances. Match to within plus or minus 0.1 dB. And 1 dB equals 0.1 enter 20 divide up 10 to the x 1 minus plus or minus 1.16%. Approximately plus or minus 1%. Therefore, must use better than 0.5% resistors to meet gain matching requirements.
Professor, we can't see your
Oh,
writing.
sorry, yeah. Okay. And for doing that, I give you 8 marks, which I think is incredibly generous. It also asks you what restricts the choice. Well, restriction. And there's probably one major restriction. Our load should be 10 k ohms. Therefore, R must be 10 k ohms. That's part 3.